Dear students, welcome to the knowledge series. Under the course of EC 407 Computer Communication, we are going to discuss in the area of data link layer. What exactly the data link layer it means. A data link layer and its control is basically for a reliable network service where the data communications can be taken place in an effective manner such that even if any error is exists, it can able to detect and it can able to correct. So in another word, we can say that data link layer control is the service provided by the data link layer for a reliable data transfer from a source to destinations over the medium. So if a data communications take place and under that particular situations, if any collisions of the bits exist, then that bit where it exactly collided or where the error has existed in that particular bit level, it can able to determine under the case of a data link layer. So we normally categorize the data link layer into two parts for the flow control as well as the error control. So there are two parts we can see under the data link layer. So we will be discussing with respect to this particular segment in a way such that we can able to understand what exactly mean by flow control. So to understand this data link layer further, we will go with the basic, the protocol data units, PDU. So you know what exactly mean by protocol. The protocol means it's a rule and the rule for the data unit. If you try to see here, a term is mentioned. A frame is the name used to represent the protocol data unit, that is a PDU, at one of the lowest level in the reference model at a data link layer. So when we talk about a reference model, you may be knowing that it is a TCP IP model. So that is why it has been mentioned as a lowest level. Now when we try to see this particular figure, in this particular figure there is something, it talks about a three sections. Let us take if two computers want to communicate over a network. So under that particular situations, there is need two type of a address. One is a MAC address and another is a network address. And you know that the network address is related to the logical address and the MAC address is related to the physical address. So if you want to deliver a message to a destination locations, then you should know about the physical address of that destinations. That means if a device want to communicate with the another device, the device itself physical address should be known, and as well as the destinations device physical address should be known, over which based on the logical address or the IP address the device tries to communicate. So for this communication there are certain terms which we try to see in this particular figure. If you try to see, there is a term like a segment is shown on the left side. After that there is a packet is shown, and there is another term, it is shown as a segment. That means the packet is encapsulated with the word segment. And on the third side you try to see that a frame which try to encapsulate the packet, and the packet try to encapsulate the segment. So this is we try to see here. So there is something very crucial to understand the difference between the frame, packet and segment. If you try to see a frame, the frame is the serial collection of bits in the frame we try to see. It try to encapsulate the packet, and packet is encapsulate when you talk about a packet is as actually a fragment form of a data. So frame is a bit, serial bits, and packet is a fragmented form of a data, and this packet tries to encapsulate the segment. That is what I mean over here. Now if you come to the bottom side, you try to see frame to packet, packet to segment. It is being shown in this second figure. Now when you talk about Ethernet frame in the OSI layer 2, that is a data link layer, that is what we termed as a receiver MAC address. So MAC address is basically a 48-bit in length. That is the MAC address. And when we try to see the receiver, if it is receiving that particular data or information, then the sender will also have the MAC address. So you can try to see that there is a unique MAC address for the different device. You cannot have the same MAC address for a two device. So that's why this is being shown separately: receiver's MAC address and a sender's MAC address. Now that is the part with respect to the frame. So that is what you can see in the shaded blues. Now that that is a frame. So when we talk about a frame, this frame is trying to encapsulate the next set of address, that is a receiver IP address and a sender IP address. So receiver IP address is a logical address, and a sender IP address is also a logical address, whereas this MAC address is a physical address, and this sender's MAC address is also a physical address. So the frame encapsulated the packet, and as I mentioned in the just before that, when we talk about a packet, it's a fragment of data. So that is what you try to see here. So this is a data which is encapsulated by the next sections. So that is what we term as a segment. So segment is a TCP protocol, and this TCP protocol is having a port number. So under the port number, this particular data is being encapsulated. So that's why when we try to see in this particular sections, this segment the packet try to encapsulate the segment which is carrying the data. So that is what we try to see in the OSI third layer. Packet comes under the OSI network layer. So that is the how you distinguish between the frame, packet and segment. So frame is a collection of serial bit, packet is a fragment of data which is encapsulated with the which encapsulate the segment, and under the segment itself the data resides, and that is what the packet try to carry forwards towards the frame. Now let's see the next sections. Here we try to see the MAC address and an IP address. So here if you try to see a MAC address and your IP address are both key component to networking, but they serve different purpose and are visible in a different way. MAC address is a different things and IP address is a MAC address is a physical things and IP address is a logical things. You just think about your name is a unique name. Your name cannot be changed by the another person's name, and whereas if where you are staying, that is your logical address. That logical address can be you can change it. Today you can stay in one place, tomorrow you can stay in another place. So automatically logical address is changing, but your name you are staying in one place, or your name in staying in another place, it remains same. So MAC address is a permanent address. IP address is a temporary address or a logical address. You can take it in this way. So here, if you try to see a figure, in this one, a computer A want to communicate to the server D. That means this is a server D and a computer A. Now, under these conditions, if it is using an IP address, then that computer, if it is communicating to the server and if this server is located at a much far distance, then you need a number of routers. So that is what it is. So what you do, you communicate based on where you want to go. That means you will use an IP address from IP address A to IP address D you want to mention. That is what. But when you mention that one, automatically the computer will go from a device to device. That means computer will go to a router B with the MAC address of A to MAC address of router B, and from router B it will go to router C with the MAC address of router B to the MAC address of router C, and from router C it will go to a router D, which is the MAC address of a router C to the MAC address of a router D, and thereby your packet will be delivered. Now here one thing you have to understand, that IP address is just like a postal address. Anyone who knows the postal address can send a letter. That is what IP address means. And a letter, if you talk about a letter, the letter will travel through different levels from and different sections. So it may be a simple sections, it may be a complex section, it may be going through a train, it may be going through a van, it may be handing through a dispatcher, it may be handing through a postman. So like that, complex things will be there. But in your letter you write the address, and it goes to that address without worrying where what are the intermediate section, or how many hands it is being handled, how many hand is being put to handle that letter to reach to the destination. That you are not worried about. So in the case of communications also, we follow the same thing, that packet of a data, it travels over the network, and that this packet, it reaches to the destinations. And here one thing is important, is that just like not just like when in the case of a letter, you send the letter to the destination, but you are not waiting for its acknowledgement. But in the case of TCP/IP protocols, when you are sending any informations, it is having a written IP address also, because it has to acknowledge whether the information has reached to the destination or not. Now here, if you try to see, there is a physical address I have shown. So if you try to see this physical address, it is having a bytes, 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte, and this is defined in the hexa forms, and this there are 6 bytes are there, so 6 into 8, so 48 bits in length. Logical address is being defined like this one. You can see over here, this is a 48 bits. So that is how you try to define the case with respect to the logical address. So logical address logical address is being defined. Sorry, here this is 32. This is not 48. 32 bits. For your correction, this is a 32 bits, because this is 4 groups are there. So this comes as the 32 bits. Whereas if you go for this is IPv4 32 bits, and IPv6 it is a 128 bits for your corrections, that one. So this is a 48, 32, and this is comes as a 128 bits. So this is how you define with respect to the physical address notation is in a different format. Logical address notation is in the in this particular format. So that is how we defines the logical address and the or a IP address and the MAC address. Now we go to the next sections about the flow diagram. What exactly the flow diagram means, and why you need to study this flow diagram. As I have discussed in the during that module 1 about the handshaking, there I have talked about what exactly the handshaking means. That means when a sender A want to communicate with the sender B, so let us assume that a frame is being transferred from a sender A to sender B. So when a frame is transferred from a sender A to sender B, it arrives here. Similarly, from another frame is sent, it arrives here. A third frame is sent, it arrives here. So every cases whatever frame is being sent, and suppose if this frame has arrived at B, so there should be another handshaking is that as an acknowledgement to say that this frame has arrived in a proper order. So that means when we talk about a handshake between a sender A and B, first we say a request, then clear to send. That means it indicates that I am ready, you send it, and then it will send the data frame, and then an acknowledgement frame is being received. Then we say that okay, the frame has transferred the entire informations. So that is what we mean with respect to this particular flow diagram. A frame is being sent and it arrives at A. And another, there is another flow diagram. When a frame is sent and it arrives at B, then an acknowledgement is being sent, it arrives at this particular point. So that is what we talk as a flow diagram. As a request is sent, then arrival frame is being received by the sender. So if this two frame, when it exists during the communication of the information or the frame, then we say that this is error-free communications. That means a frame has been acknowledged back to say to make sure that the sender A has whatever the frame has been sent, it has been properly received by the receiver B. Now we look across the next segment about the framing. So what exactly the framing means? So here framing is a point-to-point connections between the two computers or a device consisting of a wire in which data is transmitted as a stream of bits. So that is what we see when we talk about a framing. In the framing, what we do, we try to create a stream of bits, and that bits is being has a certain protocols over which it has to communicate, or it has to flow. That is what we see in the case of a framing. So that's why framing is a function of a data link layer. And not only that one, these bit which is being put under frame condition, it is having a certain block of informations. So what is that block? You can try to see that a packet from the network layer, when it comes to the data link layer, so this payload field, that is the where your framing take place, it has a header file and a trailer files. This is being transferred through the physical link layer or through the medium, and once it reaches over there, this payload is trying to map whether this payload is same as this payload field. If it is same, then we say that this is a proper error-free flow control way the frame has been transmitted from the sender side to the receiver side. So that's why we are using here the terms like a packet. Packet is a generic term. It is a piece of data that received from the upper layer, and that upper layer is nothing but a transport layer. and these sections, which is a data link layer, this one tried to sense the frame, which is a small piece of a bits of data, and frame length is specific to the hardware. So based on the hardware or the device that we use it, so that it will know that which device is sending that particular frame. So frame is basically is being a packet encoder. Actually, we put that the frame has been evolved from the packet, so that's why it is a packet encoder for transmission over the link. So when the packet travels from a device, say a point A to B, then this packet will be traveling through either a particular guided media or an unguided media. So thereby there are chances that this frame size and its format may vary. So that's why this data link plays a very important role in ensuring the intact of the framing. Now we go to the next sections, the taxonomy of the protocol. The protocols under the data link layer can be put under the two class. One is a noiseless channel, another is a noisy channel. So when we talk about a noiseless channel and a noisy channel, so noiseless channel is the simplest type of a channel. Sender and receiver type is there, and a stop and wait type of a channel is there. Another simplest form of a flow control is there. Stop and wait form of a flow control is there. And under the noisy channel, we have a stop and wait and ARQ. So automatic request, this is an acknowledgement, and go back in ARQ, and a selective repeat ARQ. So this is a very important sections which appears in the university exam. So under the noiseless, you have to remember that it is a simplest type or a stop and wait. And under the noisy channel, you have to remember that ARQ should come along with the stop and wait, or a go back in, or a selective repeat. So under this particular taxonomy, exactly what we understand is that a data is there which is received from the network layer. That network layer data is being broken into the form of a frames, and when this frame it has to send, it is again protected by a checksum. Checksum used to see that how the error can be controlled, and then the frame, that is what we see here. The checksum will be there to see that if any error occurs, that how that particular error can be controlled, and the data link, this frame is being transmitted across the transmission, and assume that when it is transmitted at the receiver side, this error is being verified whether it is error is there or not. In case if this error exists, it will ask the frame to sender to resend that particular frames. So that's why there is an acknowledgement is there. That is what we see here, acknowledgement. Why the acknowledgement? In case if this frame is having an error, then it will ask for a resend of that particular. So that is how the flow control procedure is there. So these are nothing but a flow control procedures. So here you can see the certain type of a flow control. More about this one we will be seeing in the subsequent slides. So this data link control protocol actually provides a transparent way of a data transfer. So that's why we, as I shared earlier, is that we use a bit stuffing or a byte stuffing form of a controls over which this data can be sent. So over which we will be discussing further with respect to the different figures. Now here we see the taxonomy of a data link control. Now data link control, as what is exactly data link control? It provides a service, thereby the data link layer can enable a reliable data transfer between the sender to receiver over the medium. So the data link layer can be control can be categorized into three functions: line discipline, flow control, and error control. Line discipline means who should send the data. Means that is what that is very important. That means the data link layer should know who is sending the data, and if that data is sending, how much data it has to send. That is nothing but a flow control. First is what? Who is sending the data? That is a line discipline. Second is a flow control. Flow control means how much data should be sent. And third is a error control. That means how can an error can be detected and a control. That is known as a error control. So you see this in the case of a data link a control. It is just like you think about a student who is a very who is being monitored or who is being controlled like a well disciplined, and second thing is that how that student should maintain his day-to-day activities in a just like a flow control. And second thing is that in case if any error is there, how that students can overcome that error. So this is what we see in the case of a data link control. That is a line discipline, flow control, and error control. So let us see this line discipline. The line discipline is basically a functionality of a data link layer, and that provides the coordination of a link systems. So that is what we see in the case of a line discipline. Now basically what it does is that it determines which device should send the data, and where that particular data should be sent, and who is going to receive it. Now if it is a one-to-one device, a station one is sending to station 2, so station 1 should know that station 2 is the one who is ready to receive the data. So or we can say that the station 1 is inquiring whether the station 2 is ready to receive the data or not. And once the station 2 responds the acknowledgement, then the station 1 is going to send the data, and thereby the station 2 will acknowledge. So here you try to see the flow diagram. So in this particular flow diagram, what you understand is this one, is that first is the station 1 is sending an inquiry, and that is a request, and the station 2 is acknowledging, that is clear to send. That is establishment phase. This is a establishment period. After that station 1 is sending a data, and after the data is received by the station 2, it is acknowledging. So it is giving a data transfer period. So like that a data is not one continuous flow, rather it is in the form of a packet or a frame size. So depending upon the block size, the data is sent, and the acknowledgement frame is being received. And once everything is completed, and if the station 1 has nothing to send to station 2, it will send the termination frame, that is end of terminations or end of termination, that is, and thereby the station 1 and station 2 get disconnected. So here you see EOT, ACK, ENQ, ACK, all these things is one form of a frame over which the communications takes place, or the handshaking takes place between the device. So that is what we see in the under the line discipline control. So here ENQ is stands for the inquiry, and ACK is a handshaking, acknowledgement, and so this ENQ and ACK is a handshaking, which coordinate to identify the device which will start and which will transmit to the next device, and finally it is going for the terminations. Now next what we are going to see, it is nothing but a pole select. What is in a pole select? Actually the pole select method, it work on those topologies when one device is designated and it want to communicate with several other devices. That means it is a primary device want to communicate with the several devices. You can consider this as a server and these are the terminals. So this is the class of the pole select form of a flow. Now in these sections what you see is that the primary device and a multiple device consist of a single transmission. So single transmission is there. So primary device determines which device to select using the frame select. So that is what. So here in this select it will be mentioning the MAC address. So because MAC address is important, because this it has its own MAC, this has its own MAC, on MAC, on MAC. So based on that select address it will identify. So assume that this primary device is want to communicate with the secondary B. So it sends the select frame. So after getting the select frame, when the secondary B is ready to communicate with the primary for receiving the data, it sends an acknowledgement. And after receiving the acknowledgement frame from the secondary device, then the data is transmitted. And once the data is received by the secondary frame and the acknowledgement frame is sent from the secondary frame to the primary device, thereby the total handshaking is completed. So here you don't think that only one data. Here there are from this data to this acknowledgement you can incorporate here. So that means number of data can be taken place. Here it is a one-to-one device. Here also one-to-one device, but here the devices are multiple in nature. So that is what we see in this particular form of a discussion. Now the next is a pole. Now pole form of a communication you try to see. Pole method is used when a primary device want to receive some data from the secondary device. Now that is here is a secondary device, and here the secondary device want to send a data to the primary there. So so what the primary device will do, it will try to look for which device is going to send a data. So it will send a pole. So it will send a pole, and from that secondary device, if it is receiving a NAK or NACK, that means negative acknowledgement frame. So if it receive a NAK, that is indicating acknowledge is not positive, rather it is negative. So if it receive a negative acknowledgement frames, so it understand that this device is not ready to share the data. So it look for the next device, station C. So if the station C is also respond in that way by sending a pole frame and NAK is received from the secondary device to the primary, then it understand that there is nothing to send. Then there also it understand that no data is there to communicate. It will try for a station B. It will send a pole, and the moment the secondary sends the data, and then after receiving the data, if it will send an acknowledgement. So that shows that the secondary B data is being secondary B is ready to share the data. So thereby the primary device will able to receive the data from the secondary device. So this is what we put under the case of the pole. So these are nothing but the different type of a flow diagram that we try to see. So under this particular case, you have to understand that this is what we carry out under the framing sections of the data link layer. So under the framing, we do this particular flow control, and I can say like a handshaking for the communications of the line discipline. So under the line discipline, what are the three things we have seen? Enquire, acknowledgement, poll select, and poll. So now we go to the next sections, which is nothing but the flow control. This is a very important sections. Now flow control basically it is a set of procedures that sends the sender how much data it can transmit before receiving an acknowledgement. Why it is need to, as the name indicates, flow control. That means you have to control the amount of flow. It should not happen that a sender is keep on sending the data, and the receiver B buffer is full, and it cannot further able to it is not able to further ready to receive it. So to avoid that particular situation, this particular flow control is being done. That means the receiver device has a certain limitation. And what are that limitation? Maybe that the receiver is not speed enough to process that particular frames, whatever is being sent from the sender A to the next upper layer, which is a network layer or so, or to the other devices or other nodes. So thereby what happens, or there may be a case that memory is not such a large that it can able to store it. Thereby sometime either the congestions may occurs, or maybe the there will be a error exist in the in terms of a bit level or in the transmissions modes. So there are many other factors exist. So that's why flow control is considered as the important duties of a data link layer. And the flow control it tells the sender that how you should maintain the amount of data to be sent. So that's why here we try to make use of an acknowledgement, and that acknowledgement is very necessary for the sender and the receiver to have a proper synchronizations of the flow. Now under the flow control, you can see that here one is a non-noisy channel, another is a noisy channel. So there are two types is there. One is a stop and wait, another is a sliding protocols. This is the two things you should remember. One is stop and wait, another is a sliding window protocol. Under the sliding window protocols, you have another three type: stop and wait ARQ, selective repeat ARQ, go back and ARQ. So you have to remember this one, and this is very important questions. It appears in the university question paper. So I repeat once again, the flow control is a computer network, and it defines the process of managing the rate of transmissions between the two systems. And these mechanisms, it ensures that rate of data is within the receiving capacity of the receiver modes. So that is very important to understand in the case of a flow control. So we go with the first flow control section on the stop and wait flow control. Now under the case of a stop and wait flow control, you can see this one. Sender is sending a packet to the receiver, and the receiver is after receiving it, it is acknowledging, and thereby this process it continue. That is what you can see in the second figure also. A data packet is sent, a feedback, that is acknowledgement, is sent, and again the data packet continue. Now you may be thinking, why not this is being shown straightforward, why it is inclined? The reason is that because when you're sending a packet from this point, packet itself is having some size. So automatically that is takes some time. So and this packet once depending upon the distance between the sender and receiver, packet takes some time to propagate. So that's why there is a transmission delay will be there. So that's why you can find that everything is in inclined way. So that is how the stop and wait. So you send a packet, and after that you stop for the next packet to send, and you wait for what? You wait for the acknowledgement. After receiving acknowledgement, again you send the packet, then you go to stop mode and wait for the acknowledgement. So this stop and wait is the process which keep on continuing. Now here there is certain things you understand. It is about a link utilization. That means every flow control has its own characteristics, and also every flow control has its own link utilizations. Now to understand the link utilization, this figure is a simple way to explain. So what exactly this figure means? You can see this one. This is the sender. Sender want to communicate with the receiver. You can see in the vertical way, sender want to communicate with the receiver. So this is a data packet. So this packet, you see this packet, once it start from here to reach here, so this is the time duration of a data. So data is nothing but a collection of bits, which is a frames. So these frames take this much time, so that is T data. And this data is once it sent, it will reach to the receiver, that is a T propagations. So that is a propagation delay will be there. So that is what T propagation. If you take this point and if you take this point, so that is the delay. That is what we see here. After that, after a certain time, that is a T acknowledgement, or at the same instant T acknowledgement, it is also a particular frame size. So that T acknowledgement is sent, and it takes a propagation delay, that is again a further T propagation, and it receives the sender. And after that, the next packet it tries to flow, and there is a small delay is shown here. So that's why. So here you see this one. This is a used data. This is a used data. Whereas this particular period is nothing but an ideal period. That is the time for the next data to propagate. This much period is coming. T propagation 2 times. That is 2 times T propagations and a T acknowledgement. So the entire you can say that entire frame, that is a total T frame from here to here, is nothing but a consist of a T data plus T propagation plus T acknowledgement, again T propagation. So that is what considered as a total frame. So when we say a propagation delay is nothing but a T propagations divided by the total frame T frames. So that is considered as the propagations delay. That is what we say here. So when we talk about a channel efficiency is nothing but a T data divided by the total frame. So that is what we show over here. So here T acknowledgement is very small and is usually discarded in that approximation. Now here one thing you have to understand, that this T propagation, if it is less than the total, this one is less than the total frame, then we say that the whole frame data has been received. But if you say that T propagation is greater than the T frame, then the entire frame it may not or it has not received at the receiver side, and this particular result is underutilized conditions. So that is what we try to see under the case of the stop and wait conditions. Now here what are the advantages? That This is a simple form of a flow control, because it sends the frame and it wait for the acknowledgement, and then it sends the next frame. The disadvantage is that sending a small frame for a single message, it cannot be effective, because if you want to have a better utilization, so such type of stop and wait will not be suitable, because every time you send a packet and you are waiting for acknowledgement. So in the real time, say if you are sending a video frames, so there will be a more delay will be there. You will not see the frame is being moving in a continuous way, so there will be a delay will be there. So that is what we see in the case of a stop and wait. Now we go to the next is a sliding window. This is a very important form of a flow control. And now here, to understand this one, you should understand what this sliding window means. The sliding window, actually it's these protocols are of a data link layer, and this is reliable and a sequential delivery of a data. That means you are not sending a one by one data, rather you are setting a selected window of a data, and this sliding window is used in the transmission control protocols. So here, if you try to see here, a window is created 1, 2, 3, 4, 5. So I can say that let us take it is a 5 you can take as a bits. These 5 bits is there. So you want to transmit first bit, second bit, third bit, fourth bit, and fifth bit. Assume like that one. So if this bit has to transmit, so if the first bit is transmitted, after that then the remaining remaining window is a squeeze window. Okay, so that is how it will be. So when the first bit, after sending, if it receives the acknowledgement, immediately this window is moved to the next. So that means after sending the first bit and its acknowledgement received, you will see that the new window is shifted by one more level. That means it has gone to 2, 3, 4, 5, and 6. So this is the initial window. After the every shift of the data and its acknowledgement, it will slide to the right side, depending upon the how the particular flow is being assigned. So to understand this one, you can see over here. Now in this particular window, to keep the track of the frame, what we try to see, the sender window is shown and the receiver window is shown. Now the sender and the receiver maintain the list of sequence. So you can see here the same sequence is being shown here also, but this is yellow color, this is a pink color is being shown. So this is nothing but the list of sequence. Now for a let's now in this case, what we can try to see here is that the 2 bit is being sent. So you can see here frame 0 and 1 is sent. That means it is sending a 2 bit from this particular window. That means if a 2 bit is sent, automatically this particular window will be the window size will be squeezing. Why it is squeezing? Because after sending the 2 bits, it has to wait for the acknowledgement. Until it is not receiving the acknowledgement, it cannot go further. It cannot slide that window. So if you want to see the, if you are sending a 2 bit, then what is the window size? 2 to the power of 2 minus 1. That is the window size up to 3. That means 0, 1, 2, 3. So that is what we say as a window size. So once this particular 0, 1 is sent here, so it has come here. So you can see this frame has been squeezed to 2 and 3. So that is what you can see in the receiving window also as 2 and 3. Now this receiving window, it will send an acknowledgement. So this is ACK 2. This is, you don't worry about this 2. You think about it is sending an acknowledgement. So once the acknowledgement is received, then it shows that the 01 has received. Then a new window is created again with respect to 0123. So that is what 2301. That means it has shifted to right side. So now this new window again is going to send. Now in this time the frame is, it is going to send only 2. So when only 2 has come here, so you can see it has squeezed to 301. So that is what you are seeing in the sender and receive. Now this one will not again slide, because why? It has to receive an acknowledgement of 2. So when the acknowledgement of 2 has received, then immediately this has it has expanded to the original size, window size. So this is how this window sliding window work. Every time after acknowledgement, the new window of 2 to the power of k minus 1 is formed, and this is how it continues. So this is what you see in the characteristics of the sliding window. Now if you look across the utilizations, in this case the utilization is better as compared to the previous case of stop and wait. So in this case the utilizations we defines in the form of u is equal to 1 if n is greater than 2a plus 1, and u is equal to n by 2a plus 1 if n is less than 2a plus 1, where we say n is the window size, a is the delay, and u is nothing but link utilizations. So this is what we see in the case of a link utilizations case. Now we go to the next sections, that is about the sections with respect to the stop and wait ARQ. Now what exactly ARQ means? ARQ means automatic repeat request. That is what we say about ARQ, and it is also known as automatic repeat query, and it is an error control methods for the data transmissions. So in case if any error exists or not, so that is how this ARQ it tries to. So this is what we see in the case of a ARQ. So here you try to see the ARQ try to create a reliable data transmissions over the unreliable services. Wherever unreliable service is there, we find this ARQ. Now if you try to see the sliding window scenario is the case of where the noisy channel is there. Stop and wait ARQ is the part of the sliding window. So here we are not shown the this particular window, rather we are showing a particular packet, because this one you should know this is how this particular packet transfer is taking place. So this we are talking under the noisy channel using a sliding window scenario also for the rest. So here we are showing, you see 010, the sender is sending. So we treat as a packet or this particular frame we are sending in the case of a data link layer. So this data link layer, this frame is sending. So when the sender sends, and after that waiting time, acknowledgement is received. So this is the case with respect to the acknowledgement and the dash ARQ. Now what here the ARQ means, you just see, to understand this one, lost data packet scenario is there. Now if you see here, a packet is been sent, and this packet has to receive by the receiver. So there is a timer that helps to solve this particular problem, whether this data is packet is lost or not. So after sending that data packet from the sender to the receiver, the sender, what it will do, sender will start its own timer. So you can see timer starts. Now within that time frame, if the acknowledgement is not received, then it will understand that the packet is lost. That means if the data packet gets acknowledged before the time expires, sender stops the timeout timer, and if this timer goes off after receiving the acknowledgement, sender has to understand that it has to retransmit the same packet. So after retransmission, sender will again it will do the same timeout timer, and again it will check. And this particular form of a timeout timer, it will try to prevent the occurrence of the deadlock. So this is what we try to see in the case of a stop and wait ARQ. So under the stop and wait ARQ, the important is that this timer. So timer plays a very important roles in this particular sections. You have to understand. Because here, if it is a straightforward receiving, then it is okay. In case if it is not straightforward receiving, if the packet breaks, then it will become ACQ, ARQ. If the packet is received, then it becomes ACQ. That you have to know. ACQ related to the packet is received, and ARQ is related to the packet it is found with respect to the packet lost, or the acknowledgement is not receiving. Whatever scenario occurs, particularly if the packet is lost, if it has to retransmit, then it is sending a ARQ condition. So that is what we see in the case of a stop and wait ARQ. Now if you see the stop and wait under the case of another case, lost feedback. Lost feedback means a lost acknowledgement. Here you see a packet is sent, but the acknowledgement is lost. And when the packet is so this under this one we will see. So a sequence number of a data packet, that is a packet 1, is sent, and if this packet 1 is having a problem with respect to the delayed acknowledgement, so it how it is going to understand. So it is going to consider that the acknowledgement sent by the receiver is lost. So in a given time, when you switch on the timer, and if within the timer if the acknowledgement is received, then it is okay. If it is not received, then it will understand that it has to resend that packet. So and again once that particular packet is sent, again it will wait for the feedback. So here discard a duplicate packet and then resend the feedback one. Then that means the previous packet which was received, either it will keep that one and discard the repeated packet. Now here the important is that in this case there is a deadlock situations may occur because the same packet is being received. So so to avoid that one, a sequence numbers of the packet, once it is received, it will identify that okay, this is the packet it has received. So it will not save that packet over the top. So rather it will identify whether it is a duplicate packet or not. If the receiver receives that duplicate packet, it will discard it, so that it will consume that, save that time and save that process. So under the case of a lost feedback, only the advantage is that the repetitions of the repetition of the duplicate packet can be avoided. But the questions remain same, is that if the acknowledgement, if it is lost, the packet has to resend. So this is what the case with respect to the case under the ACQ, or the lost acknowledgement. Now third we see that lost feedback. Now under this particular case, we are trying to see that it is sending the feedback has sent, but it has not lost. It takes a time to reach. That is what we try to trying to see reach here. So here sequence number of the acknowledgement is going to help to solve the problem of the delayed acknowledgement. Now here you see timer is on, packet has an, so this packet has not received in a given time, it has received here. So what it will do, it will send after the timeout time again a new packet will send with a timer, and once it is received, it will try to reject this one because it's a duplicate packet, and it will retain this one. And after that it will assume that it is going to send the feedback, because this feedback was not received, that's why it has sent this packet. So this will send the feedback, but it will try to see that by the time this feedback receives here, this feedback which was delayed, it has received at this particular point. That means a discarded duplicate packet has already received the previous one. So that it will keep the previous one and discard the new feedback, because the in this case two duplications will be discarded. So that means on the packet side it will be discarded here. Here the feedback side, this will be discarded here. So this is what we see here in this particular case. Now we go to the next case. Next case is that if the packet is corrupt, send a packet here in this particular case, and it has corrupt, so it will send a negative acknowledgement because this packet has to reset, and again it will send us a packet. So if the receiver receives a corrupt data packet from the sender, it sends the negative acknowledgement to the sender, and NAK requests the sender to resend the packet. So this is how the stop and wait will work. The same scenario you can put under this case also. Last feedback case of the damaged packet also you can understand the same. So you can this is the same thing has repeated here. So you can discard this one, only you can select up to go up to this damaged packet. So this is what we see in the case of a stop and case. Now next we will go with the okay, coming to the stop and wait ARQ, the advantage is that as compared to the stop and wait protocol, the ARQ protocols data packet and acknowledgement has a number of sequence number. Here sequence number we follow. The disadvantage is that in this particular case the limitations with respect to the ARQ case is that it is having a less efficiency, and to increase the efficiency of this stop and wait ARQ, we will see the next two type of flow control, that is a go back and a selective repeat. So when we that is what we see here. And one more thing point, under the stop and wait hierarchy, the link utilization is there. That link utilizations we defined as a u is equal to 1 minus p by 1 plus 2a, where p is nothing but your probability of receiving a bit in error, and a is nothing but a propagation delay, and u is nothing but your utilizations, link utilizations. So let us see the go back n case. So go back n case protocol is nothing but here again you are having your window is there. So based on the sliding window, because you are using a sliding window will be there for the go back at the center side. This is your center side, this is the receiver side. So here you are sending a packet, first packet. So when this packet is sent in the case of a go and back conditions, what the window is going to do is that it receives that packet, and after that the next packet is also sent, it is lost. After the third packet is sent, it is discarded. Fourth packet is sent, it is discarded. Why it is discarded? Because and assume that once the first packet has sent, it has received the acknowledgement, and once this packet is sent and it has received for the P1, and once the P2 packet is lost, even if the P3, P4, P5 will be coming, it will be discarded. So after this one, it will request resend the P2, P3, P4, P5. That means here the technique is the sender sends the data frames depending on the window size, what you say, to the receiving sites, and here the sender can send many frames without waiting for the acknowledgements. It is not waiting for the acknowledgement, but it will try to see that if any error is detected, then it will it is going to send a negative acknowledgement. Say for example, you can try to see this one, this packet is lost. So this packet is lost means immediately from here a negative acknowledgement can also be sent. So if the negative acknowledgement is sent, immediately it understood that the packet 2 is not received. So the packet 2 is not received, so that indicates a negative acknowledgement. After that, whatever packet you are sent, based on that automatically the acknowledgement has indicates. So then thereby it will discards. Now assume that assume a case like this one, P2 has received, P3 has received, P4 has received. Now if a P4 is sending an acknowledgement, so automatically it will assume that P2, P3 has already received. So that is another way of in the case of a go back n. So here what you for your understanding, P1 is received, acknowledgement is received, P2 has lost, so automatically it will send a REJ. This acknowledgement is we termed as a RR. So this is a RR acknowledgement receive message, and here it is a REJ, that is an acknowledgement reject case is that. So this is a receive acknowledgement and this is a reject acknowledgement, and after that it will resend. So that is what we see in the case of a go back n. And in this case the utilization is that one, if n is greater than 2a plus 1, then u is equal to 1 minus p divided by 1 plus 2ap, and when n is less than 2a plus 1, u is equal to n into 1 minus p divided by 2a plus 1 into 1 minus p plus np. So this is what we see in the case of a link utilizations, where we find that that instead of sending one by one packet, you can say a bulk of packet, but in case of error, those packet where the packet has created error, that one followed by the remaining one, we has to send once resend it has to do. Now that is what we see here. We are sending go back n ARQ. You can see this is the window. It keep on sliding. So you are sending 0, 1, and these 2 has come, so it's okay. Then, but when the second has lost, and then after that whatever is sent, it is being discarded because second has not received. So after that, after a given timeout, again the packet is to be resent. Window is resending this packet after a given timeout. So here you can use a timer. If you are not using a timer, then you are going for a RR1 situations. Finally, we are sending a selective repeat. Selective repeat is the same form is that you are sending a particular selected frames, frame 0, same thing. Then you are sending a frame 1, and so that is what frame 1 is sent. So no, 0 is sent, it has received. Frame 1 is sent, you have received. Then you are sending an acknowledgement. After that, frame 2 is sent, it has lost. When frame 3 is sent, after that it is sending the NAK that it has negative acknowledgement, it has not sent. Then it will be going for a frame to repeat that frame 2 onwards. So that is what. So here you can see that based on the sliding and based on the acknowledgement, negative acknowledgement, this timer, this form of a selective ARQ works. Now you may ask, sir, can we use a timer here? Here, if you are using a negative acknowledgement in a given time frame, so you no need to wait for a timer. But if you are using a timeout mode, then instead of waiting for acknowledgement, you based on your timer you can able to decide. So this is how the selective acknowledgement is also work. And here the link utilizations under this particular case is n is greater than equal to 2a plus 1, then the utilization is equal to 1 minus p, and n is less than 2a plus 1, then utilization is equal to n into 1 minus p divided by 2a plus 1. So this how we come to the sections with respect to the error flow. You can say the flow control under the data link layer. So this is the one important sections you have to study, and you repeatedly watch this particular video so that your doubts will be clear. Now in the next sections we will be talking with respect to the error control. So with this we stop here with on the flow control. Thank you.